Okay, now that we're done playing with Kami, we're actually going to get into our actual lesson here, so hopefully you have your Kami open. Today we're going to take a look at surface area with formulas. So yesterday we talked volume inside of this shape. Today we're going to take another step to that outside part of the shape, what you would paint, and look at some of the formulas we have available to us. We previously just looked at it as finding all the areas of those outside figures and adding them together. So a rectangular prism, we've got 2 times the length times the width, plus 2 times the length times the height, plus 2 times the width times the height. Really using all those possible combinations of dimensions and multiplying each by 2 because there's 2 of those pairs, that top-bottom pair, left-right, front-back, and so on. One of the formulas that I think needs the most discussion is that right triangular prism because of the width and the height. When we're talking about a right triangular prism, width and height have to do with the sides of our right triangle, and they make up the sides of the right triangle that are perpendicular to each other, that form that 90-degree angle. Then we have the length. I always think of the length as that distance between the two bases, and I think this is an important note to take. Distance between the two bases. And the S is what we call our slant or our slant height. Later on, after Easter, we're going to talk about something called the Pythagorean theorem, where we're going to talk about S, the side opposite a right angle, as the hypotenuse. But for now, we're just going to refer to that as S. And just so you know, when we take a geometry test, which I'm thinking Friday, April 24th, that's a working plan at the moment, you would be able to use all of the formulas. So you do not have to have these memorized, okay? Cube, pretty straightforward, 6s squared, 6 times the area of that square. When we look at our square pyramid, we've got S, and then here is referring to the 4 triangles. The 2BH, where we have our base of the triangle and the height of the triangle. The height of the triangle, the height we use for surface area, is on the outside of our pyramid, whereas if you remember yesterday, we talked about the height for volume being on the inside. Okay, we've got our cylinder formula we discovered using our toilet paper roll earlier in the week, and then we've got the cone, okay? The cone, we've got pi r squared, so that circular base, and then pi r L is the cone part, where L is what we call the lateral side length. And that's here on the outside, that outside edge of the cone. And then a sphere, 4 pi r squared. Here's our sphere, that's just a shadow of the sphere to show it as 3-dimensional. Okay, so let's put this into practice now with a few of our problems. Okay, so part of my problem got cut off when I was printing. That's okay, we'll roll with it. The directions were to find the surface area, and we're given a cylinder. So we've got some labels here. Write the appropriate formula. It's a cylinder, so I'm going to write the surface area formula for a cylinder. Every time I use a formula, I'm writing it down. 2 pi r squared plus 2 pi r h, and we should be referencing our formula sheet. So when we label the diagram, we just want to identify what are these dimensions, what do they represent. So 6 centimeters is our height, 10 centimeters is that's the diameter. So if our diameter is 10, we know our radius is 5, and that we're going to use here. And let's leave our answer in terms of pi. So 2 pi times 5 squared plus 2 pi times 5 times 10. Order of operations, we'll do our exponent first. 5 squared is 25. Now we'll do all our multiplication. 2 times 25 is 50, so we got 50 pi. 5 times 10 is 50, times 2 is 100. 100 pi. These are like terms, so we can add them. Our surface area is 150 pi, and we must still include units, centimeters squared. So surface area, 150 pi centimeters squared. Okay, so now surface area of our triangular prism. This is one of the few formulas I actually have to go and reference the formula sheet as well. So let's see, let's reference it. WHLWLHLS. Got it. Plus LS. Got it, finally. Okay. Let's go and label our diagram. The first thing I always start with is width and height because I know they're around that 90-degree angle. So I'm going to say 9 is our width. Our height is 12. Then I go for our length, the distance between the two bases. I'm seeing that here at 6, which means that 15 is our S. Okay. So now just substitute everything in. Everything's being multiplied, so I'm going to use parentheses. You could use the dot too if you needed. That's an H. There we go. Now we'll do all our multiplying. Plus 54 plus 72 plus 90. Okay, now let's add everything up. 324 inches squared. Okay, number 3. In the surface area of a can of soup is 200 pi centimeters squared, and the radius of the can of soup is 5 centimeters, then find the height. Okay, so we're kind of working a little bit backwards here. I like that. We're talking surface area of a can of soup. A can of soup is a cylinder, so we'll write down our cylinder formula. 2 pi r squared plus 2 pi r h. Now let's substitute in what we know. We know the surface area is 200 pi, and we know the radius is 5. So 2 pi times 5 squared plus 2 pi times 5. And instead of writing h, I'm going to write x. Okay, so let's start simplifying. So 5 squared is 25. Let's see, 2 times 5 is 10, so that's going to be 10 pi x. 200 pi is equal to 2 times 25 is 50 pi. Okay, now these we can't add together. They're not like terms. This one has x, that one doesn't. So I've got to move the 50 pi over. Subtract 50 pi from both sides. Now, as we do this, notice these pi's aren't going to cancel. We're not dividing, we're subtracting. 200 pi's minus 50 pi's is 150 pi. So we have 150 pi equals 10 pi x. Now we have to isolate our variable. So we have to divide by our coefficient. Our coefficient is 10 pi, so let's divide both sides by 10 pi. Pi's cancel, 10's cancel. Pi's cancel. 150 divided by 10, 15. X equals 15. So our height is 15 centimeters. Okay, so go ahead, work on the next, I believe there's 5 problems for our classwork, and then submit your Kami file. If you can't get Kami to work or a touch screen, then what you want to do is post an image of your work on the Padlet. Okay, have a great day. Classic math joke for you today. What did the terminating decimals say to pi? Don't be so irrational.